and I extend a warm welcome to each of you to the ongoing 5-day training program centered around statistical analysis with Excel. Today marks the fourth day of this session focusing on correlation and regression. We are privileged to have our master trainer and research expert, Dr. Chanchala Jain ma'am, among us. This training session is organized by the Research Foundation of India and the All India Shri Shivaji Memorial Society Institute of Information Technology, Pune. It is sponsored by Parul University and Eklavya University. So, let's begin today's session with these beautiful quotes. Unlock the potential within, for every learning journey is a step towards personal and professional excellence. So, without taking your much time, let's extend a heartfelt welcome to Dr. Chanchala Jain ma'am. Over to you, ma'am.
Thank you so much, Neha ma'am.
Welcome, ma'am.
Good evening,
Very
ma'am.
good evening, sir. So very good evening, everyone present over here. We are at the fourth day of the workshop. Today, the topic is correlation and regression. In the previous days, we have seen descriptive statistics. Then I explained the chi-square test. Also, we have seen t-test, one sample, and independent samples and dependent samples. Then we have seen the ANOVA, that is one-way ANOVA and two-way ANOVA. And today I'm going to discuss about the correlation and regression, right? So as per the convention, I'll first share my sheet so that you all can understand firstly the concept, and then we will move for the correlation and regression applying through the Excel. Yes. So I think I have shared my screen. Can anyone confirm me whether it is visible?
Yes, ma'am. Visible, ma'am.
Yeah. Thank you. So friends, in the previous days, we have seen the parametric test, non-parametric test, both. The definition we have seen. We have also applied the parametric test and non-parametric test. So now we are going for the further type of inferential analysis. In that, we will see the correlation and regression. So once I'm talking about the correlation, generally, correlation is what? Correlation shows the, I think from the definition or from the name itself, it is quite clear. Correlation tells us the relationship between the two variables. So it is what? It is the relationship between two variables is correlation. That is the simple definition of correlation. Now, if I talk about because I think we all know generally we represent the correlation or the coefficient of correlation, which is given by Sir Carl Pearson. We generally represent this by small r, right? So the value of small r can be in between -1 to +1. So that means the value of r lies in between -1 to +1. It can be means minimum it can be -1 and maximum it can be +1. So there are different interpretations of the values of r, right? If I say the r is -1, that means it is a perfect negative correlation. If I am saying r is +1, I'm saying that R is the perfect positive correlation. That means when we talk about the correlation indicates two things. Which two things? It shows you the direction of relationship and it shows the strength of relationship. So with the help of correlation, we can understand two things. The first one is the direction and second one is the strength, right? So direction means whether the variables are going in the same direction or different direction. That means the variables are positively related or negatively related. This is what we can say. This is the direction. So it can be positive or negative. right? So when I talk about direction, so I can say the correlation can be positive or correlation can be negative. So once if I talk about positive correlation, so positive correlation means when the variables are moving in the same direction. That means, or I can say when the direction of change is same. It is known as positive correlation. Means a very simple example we all have studied usually in economics classes, maybe or not. So maybe we have heard about there is a uh, law called supply and price law. In that we can say this thing that when we are increasing the price, supply also increases. So that means the direction is same. One thing you are increasing, second thing is also increasing. If you are decreasing one thing, other thing is also decreasing. That is a kind of positive correlation, right? Now positive correlation we can indicate by the positive sign or the plus sign. This is we are representing by plus sign. Then talking about the negative correlation means when the variables are moving in opposite direction. So we can call it as a negative correlation. That means the direction of change is opposite. So it is known as negative correlation. And this we can, and this, just a minute, and this we can understand with the help of minus sign. That is negative sign. So if you are increasing one variable, other variable is decreasing. So very simple example, if I say, uh, just a minute, friends, my laptop battery is getting down. Just a minute. Give me a second.
Sure, man.
Yeah, I'm back. Sorry, the battery is low. I forgot to plug in. Yes. So now I was talking about negative correlation. So as I said, when we talk about negative correlation, so the direction of change is opposite. So very simple example, demand and price law. So when we increasing price, demand decreases. When we decrease price, demand increases. That means when you are increasing one variable, other variable is decreasing, or when you're decreasing one variable, other variable is increasing. It is known as negative correlation, and negative correlation we can understand with the help of minus sign, right? Now R values can be very different. Usually in various books, the interpretation of R or the ranges of R can vary, right? But if broadly I say R can be equals to 0, so it shows no correlation, right? Similarly, when the value of R is in between 0 to 0.5, it is a moderate correlation. Plus or minus, according to a sign, you can say moderate positive or moderate negative correlation, right? When the value of R is in between 0.5 to 0.75. Sorry, I forgot this would be the law. Sorry, low. You can call it as a low correlation. And then this is your moderate correlation. And lastly, when the value of R is greater than 0.75, generally it is known as high or strong correlation, right? So this way, generally or broadly, we can divide the correlation figures like this, and on the basis of that we can understand whether the variables are strongly correlated or they are moderately or low correlated, right? So low means this is a weak kind of correlation between the variables. So that way you can understand this thing, that R or the coefficient of correlation tells us the two things. First is the direction of the relationship, and second is the strength. Strength means whether the variables are positively correlated, strongly, moderately, or weakly. So that way, this is the things about the correlation. Now, if I talk about when we say this thing correlation in Excel, so generally maybe you people have heard about Carl Pearson's coefficient of correlation. Yes? Any one of you have heard?
Yes, ma'am.
Yes. So this is
Yes,
being,
ma'am.
yes, thank you for confirmation. This is we are generally represented by R, but there is one more correlation, that is Spearman's rank correlation. So there is a difference in these two correlation. When we talk about Carl Pearson's coefficient of correlation, this is generally we are using the variables, means the type of variables for Carl Pearson coefficient of correlation will be numeric. Means generally, as I said, we are talking about correlation, so we need to have at least two variables to find the correlation, and the nature of variable should be numeric. That means that those variables should be quantitative. So in those two variables, we can easily find the coefficient of correlation, that is Carl Pearson's coefficient of correlation. So the basic requirement for the coefficient of correlation is the variable should be numeric, right? That is on interval scale or on ratio scale. Is it clear? Hello.
Yes, ma'am.
Yes,
Yeah,
ma'am.
fine. Now talking about how we can apply this correlation in Excel. So there is a function called correlation, and in that you need to pass your arrays to get the value of correlation. This is the one way. And second way is using the data analysis tab. We can, or using the data tab, under that we can find the analysis toolpath, and that way we can apply the correlation, right? So these are the two ways to get the correlation. So this is the basic concept about the correlation. And generally, when we talk about correlation in statistics, so correlation is a very important statistical tool, because using the correlation, we can generally means say for example, if I talk about the regression, this is the next tool of the day. So when we talk about regression, so for applying the regression also, we need to know how much is the relationship available among the variables which we are considering for the regression. So that means we can say somewhere correlation is the precursor or prerequisite of the regression tool, right? But it is not like only for regression. For any other advanced statistical tool also, we need to find the value of correlation, because if variables are correlated, only then maybe various other statistical tools are possible. If variables are not at all related to each other, that means if they are not showing any kind of relationship, so might be possible we cannot find any further kind of other relationship in those variables, right? So that is why correlation is known as the basic statistical tool in statistics. Now, further, if I talk about the other thing, that is when we say cause and effect relationship, can anyone say anything on this? Can we say correlation is telling us the cause and effect relationship? Yes.
Yeah, as we are definitely checking the relationship between the two variables. So both the variables are dependent on each other. So that's why we can tell like this may be the cause.
Yes. So, ma'am, Nidhi ma'am, I think so. Nidhi ma'am, can I say using correlation I can find such kind of relationship?
Yeah, definitely. Again, it depends like what is the factor I for that. So on the basis of that, if the factor R is going to be more, then definitely the like the percentage of correlationship is as it is going to be more. So we can find more number of like factors.
Okay. Okay. Anyone else? Anyone else?
No, ma'am, I'm not sure.
Okay, no problem.
Yes, ma'am, the effect of food on health.
Sorry, sorry, ma'am.
Cause and effect means the effect of food on health, like
nuts increasing weight and so on like that.
Okay. Okay, fine. Okay. So
Ma'am,
I think
when one variable change, the effect is shown on the other variable.
okay. Okay, fine, Kuldeep ma'am. Thank you.
Ma'am, demand and supply could be another example.
Uh okay. Okay, fine. Thank you, everyone. Yes, I think my question was little different. I was asking to the participants of this meeting that if I say a cause and effect relationship, so can I find cause and effect type of relationship using the correlation? So answer is no. Correlation can only tell you the direction of the relationship. It has the ability to tell you the strength of the relationship. Because if I say the value of R is in between -1 to +1, that means it is in terms of percent. If I say it is maximum 100%, right? So if I am saying the relationship between two variables is 0.78, that is 78% relationship is existing between the two variables, right? That means that is the strength of the relationship between the variables. Similarly, if sign is positive, so we can say the direction is plus or positive direction, right? But if I say, can correlation tell me which variable is cause variable, which variable is effect variable? No, that is not the capacity of correlation, right? Correlation cannot tell you the cause and effect relationship. If we want to study such kind of relationship, we need to go for the next tool, that is regression. Regression can tell us the cause and effect type of relationship. In regression, generally, we can say this variable is the dependent variable and this variable is the independent variable, right? So if I say dependent and independent, so in that case, the cause variable, sorry, the cause or the independent variable, just a minute, or the independent variable will be your cause variable and dependent variable would be your effect variable, right? So this way we can understand that in regression we can do the study of cause and effect type of relationship. So if any variable is affecting or making a change in other variable, that way we can clearly say that this variable will be the cause variable, and the other variable in which we are looking the changes are happening, that variable will become your effect variable, right? So regression is the next tool generally which we are using to do the forecasting. If you want to forecast or if you want to predict, so generally we are using regression. I think nowadays we are listening the terminology machine learning and etc. Algorithms and all. So generally if we talk about the machine learnings and all, so in that generally regression is used. Regression is one of the tool which we can use in machine learning. Using that we can do the predictions. I think we can say this thing. Say for example, I want to predict the behavior of a customer. The customer who is entering in the mall, whether the customer will purchase anything or not from the mall. So if I want to do such kind of prediction, how I can do that? That I can do using the regression models, right? So there are variety available in the regression. There can be simple linear regression, multiple regression, logistic regression, ordinal regression. So using those high class regression type of tools, we can do such kind of predictions, right? So regression is a very important tool nowadays, which we are or which companies or the developers are using to do the forecasting and to do the prediction of the variables, right? Now, if I talk about here, in terms of,
Ma'am,
yes,
which type of regression model we use for weather forecasting?
ma'am, totally, generally, firstly, you need to know this thing. Say, for example, if I say simple linear regression, right? So this
Yes.
is the very first tool or very simple form of regression. So here I am having two variables. Generally, you need to have only two variables. First should be your numeric, means both the variables should be two variables. Both the variables should be numeric variable. Here you can take one dependent variable and one independent variable, right? Now, if I talk about, as you are saying, weather forecasting. So whether whether the rain will happen today or not, right? If such kind of forecasting I need to do. So that means this is a kind of means this is a dependent variable, and the nature of variable will be categorical. So for doing such kind of prediction for the categorical variable, we are generally using logistic regression. Maybe you have heard about logit or something. So that is known as logistic regression.
Okay, thank you.
Yeah. Now, if I say variety, which we are going to study today, that is the simple linear regression, because with the help of Excel, we can do simple linear regression and multiple linear regression very easily using the data analysis tool pack, right? So if I talk about simple linear regression means we will having only two variables, two numeric variables. In that, we will treat one variable as a numeric, as a dependent variable. Another variable we will take as a independent variable, right? So if I want to predict one independent, I want to predict one dependent variable using one independent variable. So this kind of regression is known as simple linear regression. And as I said, we are generally developing the model using regression. So the model line or the straight line which we are using for the simple linear regression will be y equals a, that is alpha also we can write alpha plus bx plus e. Usually this is the simple linear regression, right? Y equals to a plus bx plus e. So here, I think in maths also we have studied this particular line. This is known as a straight line, right? So y will be your dependent variable. A will be your intercept. B will be your slope, and E will be your error term. That is residual. Okay, fine. So this would be the meanings or the notations of this particular regression line or regression model. Y equals to a plus bx plus e. Y is dependent variable, a is intercept, b is slope, x is independent variable, and e is your error. Is it clear?
Yes, ma'am.
Yes. So this is known as simple linear regression, right? Now, talking about the multiple linear regression. So multiple linear regression means where we are having one dependent variable and more than one independent variables. That is known as the multiple linear regression. So here your dependent variable would be numeric and independent variables can be numeric or categorical. Means it can be any combination of, maybe we are having one numeric, one categorical, or maybe we are having two numeric, or maybe we are having more than or two categorical variable, suppose we are having. So that way, this is known as multiple linear regression, where your dependent variable nature will be numeric only, right? So this is known as multiple linear regression. Now talking about y, we can write as here y equals to a plus b1 x1 plus b2 x2 plus e. So here I can say again y will be our dependent variable, a will be our intercept, then b1 comma b2 up to suppose bn, coefficient of independent variables x1 comma x2 up to xn. These would be your IVs, right? And E would be your error term. That is your residuals. Okay, fine.
Yes, madam.
Now we
Ma'am,
will
can you give us an example?
of what?
Multiple linear regression.
Say, for example, sales of a company. It can be dependent upon so many factors. Maybe how much I am investing in the advertisement expenditure. Then what is the maybe season, right? Season can also impact my sales. Similarly, what type of offers and discounts I'm offering. So there can be a number of factors which can affecting my sales. So if I'm having sales as a dependent variable, so there can be a number of independent variables which can affect the sales. Similarly, the production of crop can be dependent by so many factors. The quality of the soil, the fertilizer I'm using, the quantity of water I'm giving, something like that. So that is known as multiple linear regression. The price of a flat in a locality can again be depending upon so many factors. What is means where the locality is situated, then how is the environment, what type of facilities are available. So there can be n number of factors which can affecting the price of a flat in a locality, right? So these all can be the examples of few examples I think I have given for the multiple linear regression. Fine.
Okay, thank you.
Okay. Now talking about the term residual or error term. So with the help of regression line, suppose as I have written, I'm copying to save my time, just a minute. Suppose I have written this is the equation, right? I have written this y equals to a plus bx, right? And suppose when I have applied regression, I will get the value of a. So suppose it is coming as 28.15. Similarly, b is coming as suppose 2.63. Now, if I'm having this figure, right? And as I said, I want to predict y. Y is the dependent variable. I can put any value of x here, because x is independent, which can accept any figure or any value, right? So I can keep here any value. That value I multiply by the value of b, and then I'll add that multiplication in the value of a, and that way that would be the value of y, right? I think it is very simple maths, we all know, right?
Yes.
Yes. Okay. Now talking further, so this way we can predict the value of y, but that is the predicted value of y, right? That is the estimate or predicted value of y which we are finding using this model line. But I think it is not necessary whatever prediction we are making, that would be the actual value of y, right? So that means there is a deviation in the predicted value and in the actual value of the y, and that deviation is known as error term, right? Clear? Clear? So I
Can
hope
you
clear.
explain that error term again?
Difference of actual and predicted is known as error term.
Okay.
Clear to all?
Yes, ma'am.
Yes. So this way, this is known as the error term. So that is why we are adding here. Sign can be anything. It can be plus also. It can be minus also. So that way we are completing our regression line, right? So similarly, when we talk about this multiple linear regression, in that also we can do the same type of thing, and that way we can find the error, right? Now, how we can apply the regression and correlation using Excel for the purpose, I think I have shared a sheet with all of you on WhatsApp group. Yes? I hope you have found it.
Yes, ma'am.
Yes.
Yes.
So I expect everyone to open our same sheet and tell me if you all are ready to perform correlation along with me. So shall I proceed?
Yes, ma'am.
Okay. So
Yes, ma'am.
friends, we can, yeah. Fine, ma'am. Thank you. So friends, we can see here, we are having the two variables available in this particular sheet with the name temperature in Celsius and the ice cream, sales of ice cream in rupees, right? So these are sales of ice cream in the quantity term is given to us, right? So now we can see here that temperature and sales of ice cream, two variables are given. So the nature of the variable is
Hello?
numeric. Yes. 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 Okay, no problem, I think, right?
No, ma'am.
Okay, fine. Just a minute. So I'm back, coming back to my sheet. Now we can see here that we are having temperature and we are having sales of ice cream. So both the variables are numeric in nature. So for the purpose, I think with the help of correlation, we can find the correlation. So here we will apply the Karl Pearson's coefficient of correlation, right? So here, suppose I'm writing firstly the hypothesis. I can say between fine. I think hypothesis is very simple and clear, right? Right? Is
Yes,
it
ma'am.
clear? Yes. Now, talking further, just a minute. How to apply correlation? So there are two ways using the Excel. The first one is you can put a equal sign, and once you will write COR. So you would be able to see a function is coming CORREL, right? So we can take this function here. And then it is asking us to pass the two arrays, right? So you need to select the observations of both the arrays or of both the variables like this. And you can close the bracket. I hope you people have done this. Done?
Yes.
So may
Yes,
I press
ma'am.
enter? May I press enter? Yes. So I hope we can see here the value of correlation is coming here, that is 0.77. So can anyone tell me what would be the interpretation here of this 0.77?
These two factors are highly correlated.
Yes, these two variables are highly correlated, right? And that correlation is approximate 77%. So that means approximate 77% relationship is there between the two variables, right?
We will have to create a null hypothesis also here.
I think this is the null hypothesis only, ma'am.
So we will reject this hypothesis if it is strong correlation.
Yes, because this is a strong correlation, so we can reject, because in Excel there is no way to find the significance as the way we have done in the ANOVA, and in case of T also we have seen we will get the P value there. Using that P value, we can easily find whether the particular relationship, particular hypothesis is accepted or rejected by us. But here in case of Excel, it is not given here, right? But still, I'll try to write a formula here for you, just a minute. But the formula is little tough to write, but still I'll try for you people. Formula is T is equals to R. Then I'm writing SQRT. I think everyone is understanding, right?
Square root.
Yes, yes.
Very good. Thank you. So I think I need to use this box to give you the difference, what I'm writing, right? Divided by SQRT in bracket, it is 1 minus R square. So I think it is possible for me to write here. So this way we can find the value of T. And this t value will tell you whether your correlation is significant or not.
Ma'am, can you post that formula in the chat box, please?
Yes, yes, I'm copying and putting it. Just a minute, sir. I think I have shared. You please check.
Yes, ma'am.
Yes, ma'am. Thank you.
Yes.
Yeah. Can I share a situation where in medicine, during summer, we have cases of diarrhea. So we generally sell more of anti-diarrheal. So does the summer temperature results into diarrhea? Can we have a correlation? Means here it is a strong correlation between temperature and ice cream sale.
Yes, yes.
So there also it will happen that since the temperature is high,
Chances
more-
can be there, but we cannot do any prediction in that. It can be there. And usually when we talk about numbers, so there is a possibility that we will get some value of the correlation there, right? But to check whether that is means that particular temperature or that weather is impacting or causing that particular thing, that particular disease or something. In that case, I think further we can go for the regression.
No, because during sales figure, when we give a target to a medical representative, we
Yes.
generally follow a rule that in summer we can sell more antidiarrheals as compared to winter or rainy season, winter or other season. The rainy and summer season are more prominent. So we generally give targets based on that only. That is forecasting, you can say.
Yes. So we can use, sir, we can do that, but still I'll suggest you, if you are from the same background and if you are doing such kind of work, and if you want to implement this thing in your business or something, so in that case, maybe you are having the past records, past data, maybe you are having,
Yes,
right?
yes.
So
Yes.
on the basis of that, firstly, we can do the analysis of the data, and that way might be possible we can make strategies.
Okay. So past data we can use for this
Obviously,
analysis.
sir, because past data only we will have. Here also we are having the past data of a
Okay.
particular temperature on particular days and the sales on a particular day. So it is a past data only.
Okay. Thank you.
Yeah. I think someone has raised the hand. Anyone wants to ask me something?
Ma'am, I want to ask question regarding those students who are having the greater mark in prelim are having the chances of getting better mark in the end sim. So can that correlation be built with formula or any other regression or correlation? We should go for correlation.
Ma'am, regression is the next process. Firstly, you need to always check correlation. Once I'll tell you how to apply correlation using, regression using the Excel. There also you will find that in the output of the regression, we are getting the value of correlation. So I think I said this thing when I was discussing the concept that correlation is the precursor, or it is a kind of prerequisite for the regression, because variable will have relationship only that way they will impact the other variable.
Thanks, ma'am.
Yeah. So any other query?
So for the given table right now, whatever the calculation which you have done for R, or this temperature and sales of ice cream.
Yes.
And right now we can calculate the T for the same table.
Yes, yes.
Using the same formula.
Yes, ma'am. You can use that. Okay. Because everything is there in the formula and every notations, I think you people are familiar with.
And is the number of factors are there?
Yes. No, not factors, number of observations.
Number of
pairs, number of pairs of observations. So shall I proceed?
Yeah.
Yes.
Yes, ma'am.
Yes, just a minute. I think I mistakenly I have stopped sharing my screen. Give me a second. We were on Excel, I think. Yes. So this way we can see this thing, that this is a value of correlation and which is very strong correlation shows, right? And I think according to the data, and I think according to this particular concept also we are knowing this thing, that there should be a strong relationship, because we know once the temperature increases, sales of ice cream generally increases, right? So there should be a positive correlation and there should be a strong correlation. So that we are finding with the help of data also. Now moving ahead and talking about the other way through which you can apply this correlation. So for the purpose, you need to go to the data tab. You can use this data analysis. Here we can find the correlation is available and we can click on OK. I hope you people are able to cope up with me. May I proceed?
Yes.
Yeah. So here we are passing the range of the data. Data is grouped according to the columns. So we will go with the by default option. Labels I have selected, so I'm checking this box. Output I want to generate in this cell. Maybe this. Yes, I'm pressing OK. So I think I'm set. May I press OK?
Yes.
Yes. Yes, fine. So you can see now we are. Sorry. Any query? May I proceed?
Yes, ma'am.
Ma'am.
Yes, ma'am. Yes, ma'am.
Hello.
Yes. So here
Hello.
Yes.
Ma'am, could you repeat from the data?
Sorry, what I need to repeat?
Okay, we clicked on data. After that, what we did, it was very fast actually.
I think we are continuously performing the same processes. So I thought
Yeah.
you need to go to the data analysis. At the very right hand side, you can find it. Here you need to select the correlation and then you can press OK. Here you need to give the range of your data. If you are selecting your data including the labels, you need to select this box, and then output option you need to select where you want to generate your output.
Okay.
Then you can press OK. So once, okay, fine, man. Thank you. So once you are pressing OK, you will be able to get this output. Here we can see if we want to see the relationship between temperature. So it is quite possible if we are looking for the relationship between the same data and same variable. So that would be 1. Similarly, sales of ice cream, and this is sales of ice cream. So we are getting 1. But once we are talking about sales of ice cream and temperature in Celsius, so we are getting the same relationship, that is 0.774299, right? So means these are the two different ways of getting the correlation in Excel. I hope you people have got it, right?
Yes, ma'am.
Yes, ma'am.
Yeah, so I think this was a very simple way, and through that we can find the correlation. Now we will move ahead and talk about the regression. So I expect everyone to open a sheet number 3 with the name regression. Okay, I hope you got it. I have increased the size for you people. So here we can see we are having the two variables, COVID cases and mask sold, right? On the basis of 12 months, we are having this data available with us. Here we want to do the prediction. We want to apply the regression. As I have given you, this is the regression sheet. So deliberately, I have not written anything for you. I want to know from you that which variable I should take here as a dependent variable and which variable I need to take as a independent variable. Yes.
Mass sold will be dependent.
Mark sold will be dependent and COVID case will be independent.
Okay. Okay, fine. So everyone is agreeing with this thing?
Yes.
Yes, ma'am.
Okay, so what I need to take?
Yes, ma'am.
Mass sold as a
Dependent variable.
Dependent.
DV, and next is COVID cases as a independent. Okay. Okay, quite convincing. Even I want to say the same. Thank you, ma'am, for telling me this. So it is quite clear that COVID cases will be the independent variable and mass sold will be the dependent variable. So friends, this is what I want to say. Any software has not that sense that the software will tell you this be the dependent, this will be the independent variable. We being a researcher, we being an academician, we being a human can tell this thing that this variable is dependent and this variable will be independent variable, right? Now, if this is your independent variable, so that means we are going to represent this variable by x, right? Similarly, here we are going this variable represented as a y. Is it clear?
Ma'am,
Yes.
ma'am,
Yes.
ma'am. If we take a mask sold as a independent, or the COVID as a, COVID cases as independent, sorry, dependent, then results should be the same, or it is maybe different.
It will be different, but I think it means when generally I do not need to comment anything on this. This would be the this would be the assumptions of researchers only. But here we need to use our discretion also. I think we cannot take COVID cases as a independent variable here in this condition. How the COVID cases can be a dependent variable?
No, I just want to know that if we take
Okay.
a
Okay.
that
Results will be
maybe
different, ma'am.
same.
Results
Okay,
will be
okay,
different.
thank you, ma'am.
Yes. Okay, fine. So now we need to formulate the null hypothesis here, right? I'm writing H naught. H naught will be there is no significant impact of COVID cases on masks sold. Done?
Yes, ma'am.
Yes. Now moving ahead and talking about how we can apply regression. So you need to go to the data tab. You need to find data analysis. You can click on this and you can scroll down this. You will get the regression. All the tests are listed alphabetically. So you need to scroll down to find regression and you can find it and you can press on OK. So may I? I think
Surely, ma'am.
yes.
Yes, ma'am.
Someone is saying something? No? May I proceed?
Yes, ma'am.
Fine. Now what you need to do here, I'm telling you. Firstly, it is asking you the y range. Y is the dependent variable for the Excel, right? So we have taken the mask sold as a dependent variable. So you need to select the cell range of column C range. You need to select here for the input y range. X variable is the independent variable which we have taken as a COVID cases, right? So you can select this. Now moving ahead, I have selected my data including the labels. So that is why I'm checking this box. I hope you have also done the same. So you need to also check this box. Done? May I proceed?
Yes, ma'am.
Now
Yes.
constant is 0. Constant is 0 means I think I just told all of you once we talk about this regression line. So here this is the constant, although B is also constant, but it is this particular box is asking you about this constant, whether we want to keep this as 0. So it is quite clear that why we will want to keep that A as 0, right? So that is why you do not need to check this box. Constant is 0. No, it is not 0, right? Confidence level by default 95%, but if suppose you want to test your hypothesis at 99 or some other percent, you can check this box and you can make changes in this level, confidence level, right? Output range is totally up to you where you want to generate your output options. Any one of you can choose here. So I am going with the first option, output range. Here I am giving a cell. So this is all you need to do.
Ma'am, if I change the confidence level, will the result be different?
If you are checking this box, this is what you saying?
No. If I want to change.
If you want to change, in that case, the results will not change.
Okay.
Results will not change. Results will be remain same. Only your comparison of p-value will change with the level of significance. That will change only.
Okay.
Yes. So I hope you people have done the same.
Yes, ma'am.
Right. Now you need to only press OK here to generate your results of the regression. Once you will press OK, you would be able to get the summary output. The first output table is the regression statistics. I hope you generated. May I start explaining the interpretation part?
Yes, ma'am.
Yes. So now you can see we are getting here the multiple R. Generally, the software is designed like this. So it is giving you multiple R. That this is your correlation value, right? So here the correlation is coming as 0.98. That is 98% relationship is there between the COVID cases and masks sold, right? If COVID cases are increasing, selling of mask will also increase, right? Clear?
Yes, ma'am.
Yes, ma'am.
Moving ahead, talking about R square and adjusted R square, right? So R square, I think I need to make you think this, make you people this thing clear here, that R square and adjusted R square, always your R square will be greater than to your adjusted R square, or maybe equal to, but R square will never be lesser than the adjusted R square, right? So meaning is the interpretation is same, but when you need to report which thing, that I need to clear you, right? So once if I talk about the simple linear regression, we will go with the R square. R square we are reporting in case of simple linear regression, and adjusted R square we will report in case of multiple linear regression, right? So here we will report R square, right? So I'm writing here the interpretation for you. You can write R square shows percent variance in DV due to IV, or I can say explained by IV, right? So I think rather than reading this thing, I'll explain this thing. If I say R square is 0.96, 96 means 96%. So I can say 96% variance in DV. DV is what? DV is mask sold, right? So 96% variance in mask sold is because of COVID cases, right? Means, or other way around, I can say this thing, that 96% of masks sold is explained by the COVID cases. That means almost 96% variance is coming in the masks sold because of the COVID cases. Is it clear to all?
Yes, ma'am.
Yes, ma'am.
Yes. Further, as I said, we will not discuss here the adjusted R square. So as we are talking about the simple linear regression. So this is you need to report in case of multiple linear regression. Interpretation will remain same, right? Now standard error is 141.848. Observations are total 12. Now ANOVA we have already studied in case, means one way ANOVA or two way ANOVA we have already studied. But here why ANOVA is coming? So the logic behind ANOVA is that ANOVA is telling us the significance of the model. Model means the model which you are fitting with the help of that straight line, whether that model is a good fit or not, right? So we can say here, looking at the p value of the ANOVA, which is less than 0.05, right? So we can conclude this thing here that our model is a good fit, or model is a significant model which we are fitting here, right? So this is the only use of ANOVA here. Talking about further, now you can see how you will prepare or how you will make your line. So you can see here mask sold is given here as your dependent variable, and the intercept and the COVID cases, these are the two different things. So intercept would be your A, right? That is the constant term. So its value is minus 245.631. COVID cases coefficient is 0.99456. Now you need to check whether these two figures are significant or not, whether these two are contributing anything to your dependent variable or not. So that we can check using these values. So the p-value of t, using these two figures, we can conclude this thing. So we can see both the p-values are less than 0.05. So we can conclude here that intercept and the coefficient of COVID cases both are significantly contributing to your dependent variable, that is mask sold. Is it clear? So your line will be minus 245.631 plus 0.99456 into COVID cases. Done? Clear?
Yes, ma'am.
Or rather than this, I need to write this. This would be our line. Now, if I want to predict how many masks were sold when the COVID cases were this number, so I can put the COVID cases number here, I can multiply that by this, and I can subtract this figure, so I can do the prediction of the masks sold. Clear? Clear to all?
Yes, ma'am.
Fine. So this is known as your simple linear regression. Now you can find the fifth sheet with the name MLR, multiple linear regression. I expect everyone to open the next sheet, multiple linear regression. Open. May I start explaining?
Yes, ma'am.
Yeah. So friends, here we can see we are having three variables. First variable x1, second x2, and third is y. So as a convention, we are taking y as a dv, that is dependent variable, and x1 and x2 as a independent variable. So this is a case of multiple linear regression because we are having only one dependent variable, which is numeric, and we are having two independent variables, that is x1 and x2. So this is a case of multiple linear regression. Clear? May I proceed?
Yes, ma'am.
Yes, ma'am.
So here, firstly, I'm writing my hypothesis. There is no significant impact of x1 on y. Right? Then there is no significant impact of x2 on y. These would be your two null hypotheses. Right? Clear to all?
Yes, ma'am.
Yes, ma'am.
Now we will apply the regression. So you need to again go to the data analysis and you need to select the regression and you can press OK. So may I?
Yes, ma'am.
Yes. Now you can remove if you are also getting some ranges there. Right? Now coming down. Now you need to provide the range of your y variable, that is your dependent variable. So I'm selecting it. Right? Coming to the x range, you need to select both the variables x1 and x2 together like this. Labels I have selected because we are I have selected my data including the labels. So you need to check this box. Confidence level, if you want to make any changes, you can select this. If you do not want to make changes, you do not need to select this. If you are selecting and not making changes, also it is not impacting your results, right? Now you need to come to the output option. So wherever you want to generate the output, you can give that particular cell reference and then you can press OK. So may I?
Yes, ma'am.
Yes, ma'am.
Okay. So you would be able to see now we are getting here the output of regression, multiple linear regression. So the multiple R is coming as 0.836. That means the correlation among x1, x2 and y is 0.836 or 0.84. So that is around 84%, or that is a strong positive correlation is existing between the variables, right? R square we will not report here. Rather than reporting this, we will go for the adjusted R square, which is 0.614, right? So again, I can say this thing that 61.4% of Y is explained by X1 and X2, or 64% variance in Y is due to X1 and X2. Is it clear?
Yes, ma'am.
Yes. Moving ahead, talking about ANOVA. So we can see that the significance value of ANOVA is less than 0.05. So that means we can say this thing that our model is a good fit, right? It is a significant model. Now, talking about these intercepts and the coefficients, so we need to see whether these are significant or not. So looking at the p-value, first value, second and third, all three values are less than 0.05. So that means our model is, or these intercept and coefficients are significantly contributing to your y variable, and your line will be 43.109 minus 0.818 into x1 plus 2.42 into x2. This would be your regression line, right? Clear to all?
Okay, ma'am.
Okay.
Yes.
So, yeah. So now we can see if both the p-values, all the three p-values are all the p-values are less than 0.05. That means in that case, both the coefficients of x1 and x2 are contributing to y. So that is why you will reject both your null hypothesis, right? Clear?
Yes, ma'am.
Yes, ma'am.
So I think now it is all from my side for the day. Remaining sheets are for you for practice purpose. If you are having any queries now, platform is open.
Madam, in simple regression, simple linear regression, you showed COVID and mass sold. Mass was dependent variable and COVID cases were independent. But many times what happens, can I have two dependent variables like mass sold and vaccines also?
It can be, sir, but in that case, that would not be the case of regression. Means simple and multiple regression is not possible in that case.
So which test I will implement if that type of
Usually, sir, that is
data?
the case of MANOVA.
Okay, okay,
Yes.
okay.
Okay. Any other queries?
Participants, if you have any question, please, you can ask ma'am.
Ma'am, can dependent variable be categorical?
It can be quite possible.
Can you give you an example?
I think initially I said if I want to predict the behavior of customer, whether the customer will buy the product or not, or whether a person who is taking loan, whether he or she will be a defaulter or not. So that kind of variable is the categorical variable, right?
Yes, thank you.
Welcome.
मैम आज के नोट्स डाल दीजिए ना चैट पे.
हाँ जी. I forgot to forward. I'll do that.
Sure, sure. Thank you, ma'am.
Yeah, yeah.
Thank you, ma'am.
Okay, so no queries?
No.
Oh, that's great. So now can we go for a picture?
Yes, ma'am.
Okay, very good. I need to change my layout first. Give me a second. I'm changing it so that I can see you people. Okay, I think 2, 3, 4, just a minute. So give me a second. I'm capturing. I captured.
Thank you, ma'am.
Thank you so much, everyone. Thank
Thank you,
you.
ma'am.
Thank you. Tomorrow
you,
will
ma'am.
be the last day, right?
Yes.
Yes.
Yes, ma'am. Yes.
Yes. So thank you, everyone. Good night. See you tomorrow.
Thank
Thank you,
you.
ma'am.
Thank you. Thanks a
Good
lot.
night,
Good
ma'am.
night. Good night. Good night.
Okay.
Good night, ma'am. Good night, ma'am.
Good night. Good night.
So,
Over to you, Neha, ma'am.
yes, ma'am. So, as we bring today's session to a close, I would like to convey my sincere appreciation to all the active participants. A special acknowledgement is extended to our research expert, Dr. Chanchala Jain, ma'am. I also express gratitude for the collaborative efforts of the organizing committee and sponsors. Tomorrow marks the culmination of these sessions, and I look forward to your presence. Until then, I extend my heartfelt thanks for your time and active participation. Thank you so very much.
Thank you so much, Neha, ma'am. Thank you, everyone. Good night.
Good night, ma'am.
Thank you, ma'am.